A very good afternoon to all of you. I, Sanjib Pattnaik, I welcome you all to this particular session, which is under the ambit of your course, that is MMPC 019, which is based on Total Quality Management or TQM. Uh, in the previous sessions, we had seen the basics and its implications in the first two blocks. In this particular third block or block 3, we shall be looking at tools and techniques. The tools and techniques we shall cover up in two sessions. Today we shall start with the first unit under block 3, that is unit 7, which is commonly called as Statistical Quality Control or SQC. Now, always we say, in order to sustain this cutthroat competition in today's business world, which is based on globalization and quality management, quality control is of utmost importance. Why? The reason being, customers are fed with lot of information. They are coming up with their requirements. They have different options to choose from. So unless and until we deliver certain quality levels which will beat the competition, it is very hard to sustain in the marketplace. Now, when we say quality, we use the tools of statistics. That means through measurements, simply speaking. If we can measure the quality control or the quality aspects, then yes, the things will be very clear cut and it will not vary from person to person. And the statistical quality control techniques and tools are already proven, already tested, and is being applied in various industrial sectors or service sectors, we can say. So let us go into what is statistical quality control, what are the things that we should know under statistical quality control. So statistical quality control, we say it as the SQC in short. Statistical quality control is a framework which helps the TQM approach to run, the total quality management to run. Now, what is that total quality management, or as we say in short, TQM approach? Now, from the name itself, total quality. When we say total quality, quality can crop up from inside the organization. The quality requirements also can crop up from outside the organization. Now, when we are talking of total quality management approach, we say that it is identifying customers' requirements. Now the question is, who are the customers? Now we divide or segregate the customers of an organization into two segments. One is the internal customers, another one is external customer. Now, who are the internal customers? Now, in the organization, it is not that a single process or a single individual processes the item. The item is processed up to certain extent and it is passed on to the subsequent processes to be processed further. So, the whole process of the organization can be divided into small segments which are interlinked. That means one process will become the input of another process or the next subsequent process, whereby the subsequent process becomes the supplier to the next subsequent process. So there also think about a process which is getting its input from another process in the system. Now, if the inputs from the other process in the system is not up to the quality standards, what will happen? The processing or the quality aspects in this particular department will also fail. So we say whatever we process in a particular process inside the organization, or whatever we try to deliver to the next process, should be based on quality, so that next process can further refine it and send more quality items to the subsequent processes. Who are the external customers? Now here comes the major part. It is the general customers in the marketplace. So those who are purchasing our items or buying our items in the marketplace, they are the external customers. They have certain expectation. They have certain requirements. Now, these requirements form the basis of quality of the product or the service. Now, if the organization can fulfill at least, or they have to fulfill at least this much requirements of the customer, the minimum basic requirement of the customer, then they are attaining the quality goal. Apart from that, they can add to that so that it will bring delight to the customer. So every organization should strive how the basic quality requirements can be met. Not only that, how apart from meeting the basic customer requirements, we can deliver them the delights. So we say striving to achieve it. So every organization strives to achieve the basic quality requirements as demanded by either the external or internal customers. Now, in order to have this TQM approach running, what it requires? It requires a good management system. In the earlier sessions, we have seen what is required from the management system for total quality management. However, to refresh ourselves, we can say that a good management system under the total quality management approach should focus on the quality objectives, should have a positive attitude towards the quality policies, should always try to maintain or enhance the quality aspects of the outputs that are coming out of the organization through better development of the process as well as individuals who are involved in processing the outputs in the form of product or services. So a good management system is basically required. Second, we say the statistical quality control methods should be taken up. Now, statistics will help us to guide in a scientific manner, in a numerical manner, whether our approach is moving along in the right direction. Is some adjustments required? Is any trouble being, we can say, that is occurring in the processing part? If the problem is occurring, what should we do? Now this whole total quality management requires a teamwork. The whole of the organization should work as a team. They should combine in their thinking process, in their working styles, in their learning techniques to achieve the total quality management for the organization. Now, what is this statistical quality? We say that statistical quality control is a strategy for reducing variations. Now, what do you understand by it? Uh, Let us think about, we are a organization who we produce certain kind of, suppose, ball pens, where the pen body has a cap, removable cap. All of us might have used it. A pen which has a main body containing the refill, etc., and the cap to cover the tip and hold it in our pocket. Now, if you look carefully at the pen, if you have a pen, you look at it, remove the cap from the pen's body, again put it back. You will see that it will fit nicely. That means the body will not fall off from the cap. Or while opening it also, it will not require a big enough force to separate the two things. Now here comes out the term called as variation. Suppose the body of the pen is having a diameter of 0.4 centimeter. So the cap should be at least somewhat higher than 0.4 centimeter. Because if it is exactly 0.4 centimeter, then it will not fix to the body of the pen. If the cap is having a big enough diameter as compared to 0.4 centimeter diameter of the body, then what will happen? The cap automatically will fall off from the pen, or the pen's body will come out of the cap without also applying force by us, which is not required. So while purchasing a pen also, we try to check that whether the cap is fitting exactly or not. Now the question is, how much should be the diameter of the cap's internal so that it fits the body? Because we know that if it becomes less than a certain measurement, it will not fit to the body. If it is more than a certain measurement, then the body of the pen will also fall off. So this more or less are variations. So how much variation we can allow so that the pen is having a body as well as a cap which are fitting perfectly? That is the biggest question. So statistical quality control, the techniques will help us to reduce the variations. That means it will keep under such a limit the diameter of the cap so that it fits the body of the pen. Now the variations will definitely occur. So the task is how to reduce the variation so that more number of good quality pens will come out of the system. So statistical quality control, we say it is a strategy for reducing variations. Lower the variations, in other words, lower are the defects, and ultimately we say that opposite is higher is the better quality products or good quality products. Now for this, what we use? Statistical quality control, we use statistical methods. Statistical methods like the control charts, which are based on the mean, the range, as well as we also use standard deviation. Mean is an average, range is the difference between highest and lowest between a number series. In a number series, if we arrange them in a order, the highest value and lowest value will give us, the difference will give us the range. What is that standard deviation? Now it is a measurement for the variation around the central value. Suppose I have 5 numbers. I am asked to calculate what is the mean of these 5 numbers. So how can I calculate it? I'll add all the items, divide it by number of items considered, that is 5. It will give me a value. Now I check how each of the individual items in our number series for which I have calculated the average or the mean value is differing from the mean value. That measurement is called as variation, and it is measured by a certain statistical technique that is called as the standard deviation. Statistical quality control, when we go for it, we see there are two type of factors which are influencing or causing the variations. One is controllable variation, another is uncontrollable variations or the factors. Now, how can we understand what are the controllable factors or what are the uncontrollable factors? Suppose I travel to office. On an average, I know I will be taking 10 minutes to reach my office from my house by a bike. So here, on an average, when I am saying, that means I am considering the traffic lights, the general traffic on the road on almost all of the days, and considering all the things, I find I reached my office by 10 minutes. So what I do, apart from that, suppose it is a rainy season, chances of rain on the way may occur. I will no longer reach my office by 10 minutes. It may take something longer due to maybe waterlogging, maybe due to I being held up in the traffic for a longer time, due to I stopping at a particular place so that I do not get drenched. Now, this rain is an uncontrollable factor. But on normal day, when I travel from my house to office, I am considering all the kind of traffic, the traffic signals, etc. That means I am keeping the factors under control for the time to reach my office. So statistical quality control is always affected by controllable as well as uncontrollable factor. Let us take another example. We are, suppose, a iron and steel plant industry. We require iron ore as the input. Our inputs are coming from, suppose, a particular Odisha Mining Corporation. A particular state of Odisha's mining corporation, it is supplying us the iron ores. Because we know they will be giving us one of the best quality iron ore. So we are assured of the quality of inputs. Here, However, the question is OMC has different sources to get the iron ores or different mines to extract the iron ores. Not all the mines have the same quality or content of iron in their ores. So even if OMC is supplying us the iron ores which we are thinking as qualitative, what is happening? Now they are being sourced from different sites. If it would have been from a single site, then we know that yes, we are assured of the quality. That means the variations are under our control. We know that the quality of iron ore coming from location A is having this kind of grade. But if they are sourced from different sources, then it starts varying. And if we don't have the option to choose from which source we shall get the iron ores, then it becomes an uncontrollable factor for us. Similarly, uh, many times we have seen uh, I go to a particular fast food joint. There I want to purchase certain kind of eatable item. I know that this will have this kind of taste, that particular item I have chosen, this kind of texture, this kind of feel, etc. However, not every day the same kind of taste will come out. This may vary due to various kind of uncontrollable factors like the supply sources, maybe the quality of inputs coming into my kitchen, maybe due to the uh, way the person who is cooking the dish, because we are emotional, human beings are emotional, it will change from day to day. We are feeling happy, we will be doing nice work. We are feeling upset, mostly we may produce defective items. So these factors become uncontrollable. So we try to have a thorough hand over the controllable factors so that the variations are reduced to a maximum extent. Now, what are the tools of statistical quality control? We have three basic tools. One is acceptance sampling, another one is statistical process control, third is design of experiments. Sometimes what happens while we are producing items, the items are too large in numbers. It is not possible to check each and item or inspect each and every item whether they are meeting the quality limits or the quality aspects, because the cost of checking all the items will prove to be more costly. So for that reason, what we do, we try to take samples. Now what is a sample? Simply speaking, I will give an example of, let us go to the ice cream parlor. I would like to have some ice cream, or we would like to have some ice cream. We say to the shopkeeper who is selling the ice creams at the ice cream parlor. We find a number of different varieties of flavors in front of us. Now, we do not have idea that what will taste what. Only from the name we try to generate certain little idea. But how does it feel? How does it taste? I do not know unless I taste it actually. What I will do over there? No, I will ask the shopkeeper, ice cream parlor man, that you give me testing spoon cream flavor because it feels me attractive. So what he will do? He will give a little bit out of the big container where the ice cream is being held. I taste it. Immediately I get a feeling that is this flavor is having a taste like this. And actually the whole of the big container from which a small portion was taken will also be having the same kind of taste or the feeling. Now, what we say here? Now, the whole container is our the total items, or in statistics language, we say it as the population. Whereas, instead of checking all the population for the test, that means the whole container of that particular flavor, what I do? I take a small portion out of that. That means the tested ice cream. What I find? Now the test. So the small portion is showing the characteristic of the whole population or the whole container. This small portion is called as sample. It will give an idea of what the whole lot is having. Similarly, in case of inspection, when we cannot go for 100% inspection of the items that are being produced or are being delivered to the next process, we go for sampling tests. That means if the samples pass the test, then we accept the whole production lot. That is called as acceptance sampling. Now, sometimes what happens, it is required that all the items we have to check their characteristics. That means whether the process is producing the items as required by the product. So there we take the help of statistical process control, which will be based on the certain charts. We'll see later on in this particular session that how the statistical tools will help us to know about the process. Then another tool is design of experiments. What happens? Whatever the customer requires, whatever is the item that we want to produce may be difficult to produce. It is not always that everything that we think of can be produced easily. So whatever we think, we produce in small lots. That means we carry out or conduct an experiment whether the design of the product that is being processed is going to have a successful production run. That means whether it will achieve economies of scale. So we say design of experiments or DOE. Now, where should we apply the statistical quality control? Everywhere. Everywhere in the organization because it falls under the ambit of total quality management. We start with the designing part, the product design. That means whether the product design is capable of being produced commercially and is also holding the requirement of the customers. So here we apply the statistical quality control. Then we look at the process design. Now the whole processing can be divided into various segments where the items may be processed from one segment to the other, passed on to the other segment. So here, whether the process is capable of maintaining the quality of the product or services that we are producing. Third is the procurement of materials and parts. Our production will be requiring inputs in form of materials or components or parts. So they have to be qualitative because they are the foundation based on which our final product will be manufactured. After all this thing happens, we go into the actual production or the commercial production. There, as the production goes on, we have to constantly monitor whether the items are produced according to the set qualities. And finally, the outputs which are coming out, they are tested. That means whether they are having the quality characteristics as required by the customers as well as we have designed, and we send it to the customers. Process capability. Now, we say that whatever we think of, we cannot produce or process it according to our requirements. Many times it becomes very difficult. So each process, each conversion process has its own capabilities. What do we mean by capability? That means the range over which natural variation occurs. For example, just few moments back, we are discussing about a certain example of a pen and a consisting of a body and a cap. Now, we know that exactly the body of the pen, the diameter and the diameter of the cap cannot be produced to the exact measurement. It will contain some kind of variation, maybe due to machineries, maybe due to the human processes, etc. These are called as natural variation. So, how much variations are occurring under normal conditions that we call as process capability. In other words, we say that this is the quality aspect which can be delivered under stable conditions. If all the conditions are held stable, what can be delivered? Uh, if we own two-wheelers or four-wheelers, always our eye is on two things. One is the price and more on the mileage. That means per liter of fuel, how much miles our vehicle will go. Or in another sense, we can say for driving 1 kilometer the vehicle, how much it will cost us. There, various companies also give certain kind of ideas. You might have seen a particular car will deliver 15.6 kilometers per liter. There it will put a star mark under stable condition. What is stable condition? That means whatever is being normal, like the car moving on smoothly, the road is smooth, traffics are not head to head, that means we can say back to back, jam packed, we can say. The driving at the fuel efficient gear or the most economical speed, which may not always happen. So taking different conditions, stable conditions, whatever can be delivered is called as process capability. We say that it is the fraction of output within certain specification. To be specific, we say that it is 99.73%. Come back to our example of pen and its body. How much the diameter of the cap can be so that it fits the body of the pen. That will allow the specification, the required, the minimum, the maximum. Within this specification, if we can produce 99.73%, then that is called as process capability. So here we say it is the process ability to produce within the range of engineering and customer specification. So whatever is required by customers and also feasible according to engineering part, whether the process is able to produce it. What is the range allowed to the process to produce? That is called as process capability. When we talk of capability calculations, the first condition is the process must be in control. What do we understand by control? Now here we take three examples: control charts, histogram, normal distribution, or the distribution we can say. For example, if you look at control chart, here I am showing a typical particular small example of control chart. Suppose this is the pen's cap production we are talking of. All of us find here, this is the upper, this is central, and this is lower. Suppose the pen caps average requirement is 0.405 centimeter. Lowest is, suppose statistically we have calculated as 0.401, and maximum is 0.408. What I understand? Now a good cap for the pen requires a diameter of 0.405 centimeters. It will fit to the body till it comes down to a level of 0.401. If it is below that, that means in this area, then it will never fit to the pen's cap. If it is above this, this will fall off from the pen's body. Now, if the pen caps are produced according to this range, all of us can deduce, yes, we are producing within a certain acceptable range, the pen caps. Second is histograms. Now what are histograms? We take the help of bar diagrams of the standing skyscrapers. Suppose this is 0.405, this is 0.401, 0.408. Our average requirement of cap is this one. All of you see, these are the skyscrapers. These are the minimum levels, and this is required, the highest skyscraper. So by looking at this histogram, immediately I can say my average requirement is this one, the highest skyscraper. This is an ideal condition. Similarly, when we are talking of distributions, we take the help of statistical normal distribution curve, which is our second condition, normal distribution. What is there? Now, statistically, you can check. If we plot all the data that are being produced, it will form a bell-shaped curve. All of you can see it is looking like a bell, and this is the average requirement. And on both the sides we have the upper level and the lower level. And this curve only shows the probability of what we are producing and in which area it will fall. This should have 99.73% probability. Whatever we are producing should be falling in this particular range. That means out of every 100 items, 99.73 items will be falling within this. And these axes are measured through standard deviations. Our requirement is whatever we produce should come into this particular. Now the third condition is the statistical process control. How shall we carry out? Now first is we should think where should it be applied. That means we should prepare the background. For what it should be prepared. Then we move on to collect the data on that particular aspect. Then we set the control limits. As you can see in the control chart in the upper one here, you can see the upper level, lower level, those are the control level. Now we try to analyze our production pattern. Now, if certain problem is occurring, this is a problem. Why it has occurred? How it can be rectified? Is it a controllable error or uncontrollable error? Or factor we can say. Now, when we are talking of quality improvement tools, we have 7 commonly used quality improvement tools that are here. Flowchart, the first one. Many of us must have read this in decision making flowchart. We start with a particular problem. We try to analyze what are the various offshoots, whether yes or no. If yes, then what are the possible avenues? Now this way we try to analyze till the end how the problem can be solved. Second is histogram. Just now we saw in the previous slide a histogram. That means a bar diagram which is looking like our skyscrapers. The central value or the average value will be having the tallest skyscraper, and the lower levels or the lower limits and the upper limits should have the lowest skyscraper. Third kind of tool that we use is Pareto chart. Now this Pareto analysis is based on the economic theory given by the Italian economist Wilfred Pareto in the 1900s. He discussed about wealth of the society. However, it was seen that it is applicable in almost all the cases, practical world. Now what is said? 10% of the people in the society, 10% of the people living in the society have 70% of the wealth of this society. That means we are talking of super rich people. Few but having huge wealth. Then it talks about The second category, the average wealth people, 20% of the people owning 20% of the wealth of the society. That means the common man or the common persons. Then the third category he talked about is 70% of the people who own only 10% of the wealth of the society. That means most of the people do not have that kind of wealth to live in a better way. So we have super rich, we have middle class, we have the poor. Let us change that into our quality aspect, the statistical quality. If you look at a particular process or a particular industry, then you will find most of the variations or defects are occurring due to a trivial few activities, just like the super rich. Few people, maximum wealth. Here, few activities causing the maximum damage in form of defects. So, we can focus on this few, trivial few, and if we can eliminate them, then immediately we know that yes, most of our problems of quality is solved. Most, I'm not saying all. So first, our focus should move towards this trivial few. Another is fishbone chart, which is also called as cause and effect chart. Now this is for analyzing the problem and what are the possible causes for that, or what is the impact of that particular thing. Here the problem looks like the head of a fish. And we try to find out the possible causes. Now, if a cause is having certain cause further downstreams, then we can divide them like this. And if you look carefully, it is looking like a fish bone. So the name is fishbone chart. So by looking at it, we can bring upon improvement by reducing the defects. Another is a scatter diagram. Now, what is a scatter diagram? Usually it is taken for two things. That means what is the problem, what is the basic cause. Let us go by advertisement and sales. Usually we say the more advertisement we make, the higher may be the sales. If I take sales here, advertisement, what is happening? I plot various levels of advertisement expenses and find out the sales amount. Now this will tell me what is happening if I advertise more to the sales amount. So we try to present the scatter diagram. Similarly, we have runs chart which shows the up and downs of the trends, and the control chart that we have seen, where we saw in the last slide the upper control levels and the lower control levels. Now, when we are talking of control charts, we can have it for variables, that means things that can be measured, and attributes that cannot be numerically measured. So for control charts, for variables, we have two types. One is X bar or mean chart, another one is range chart. And for attributes, we have the proportion defective or P charts. In the control charts, we try to find out whether it is X bar or R or the P chart. This is the lower control limit, this is the central limit, and then this is upper control limit, and these are the values. Here we try to look at the various patterns. Suppose we see the production is moving like this. So this is normal. What happens? Suddenly the pattern moves like this. Immediately you can see something has happened. It is abnormal. Or this is moving like this and it comes out here and again it's fall back. Now it is an outlier, means it may be due to faulty data collection, or there may be a sudden shift. Suppose this one is going on, this moves towards upward. There is a sudden shift. And cycles also. Why this is happening? You can find trends also. Here you can see the trend is moving upwards. Sometimes it will be hugging the central line, etc. You can use also acceptance sampling, where average quality levels or acceptance quality level and rejection quality levels are tested. So taking into view all this, we end our session on the statistical quality control. Thank you.